Hi class, I'm going to work on the show your work, the practice problems, and the applications of sine functions. So number one, a Ferris wheel has a diameter of 16 meters with a minimum height of 2 meters above the ground. It takes 20 seconds for the Ferris wheel to complete one rotation if a rider boards a car when it's at its lowest point. Okay, so A says to determine an equation, and then B says to sketch a graph, but I'm actually going to sketch a graph first because it makes it easier to determine the equation that way. So it has a minimum height of 2 meters, so that means that the bottom of the Ferris wheel is never going to touch the ground. So our ground here is going to be our x-axis, and then it starts at 2 meters. So this is where the rider gets on. And since the Ferris wheel has a diameter of 16 meters, so here's my Ferris wheel. So it has a diameter of 16. So when it gets to the top, remember this here is 2 meters. So when it gets to the top, the rider gets to the top and then goes back down in height, it's going to have a total height of 18 meters. So that means it's going to climb all the way up to 18 and then all the way back down to 2 meters. And this is where the rider would get off. So halfway in between our 2 meters and our 18, because right here that's 16 meters, halfway would be 10 meters. Okay, so it's 8 away from 18 and 8 away from 2 meters. So this is when our rider is going to be here and our rider is going to be here. And then it takes 20 seconds for the Ferris wheel to complete one rotation. So the rider goes up to the top and then back down to the bottom. So that would be a full rotation. So that takes 20 seconds. That means that when the rider's at the top, it's half of that. So it's going to take 10 seconds for the rider to get to the top. And for the rider to reach the 10 meters, so at the left and the right side, it's going to be 5 seconds and 15 seconds. Okay, we can use this to create the equation for it. So we're going to do it as a sine function. So our original sine functions usually look like this here. So from here to here. So you'll see that it got shifted. So there's a transformation here. So one of the transformation is that it was vertically shifted, and then it also horizontally shifted. So it went from 0 to 5. So we're going to have to include both of those in our equation. But to start, we're going to look at the amplitude. So half of our full height is 8, so that means our amplitude is going to be 8. Then we have the sine function. And then to find out this value here, so because usual graphs will either do 2 pi or 360, but one full rotation is 20 seconds, we take 360 and we divide it by 20 and we get 18. And then we got to look at the shift. So it's going from 0 to 5. So we got to put x minus 5, and you got to put these in brackets. So it's minus because remember when it moves to the right, it's a negative, and when it moves to the left, it will be positive. And then you'll see that it goes from 0 to 10. So it's a vertical shift up 10. Okay, so that's our equation for this graph. So then for question C, it says determine the height of the rider after 8 seconds. So we just put 8 in for the time. And you got to remember that you need to close the brackets because you got to do this first before you multiply by 18. So we have 8 minus 5 and then times it by 18. So 3 times 18, you'll get 16.47 meters. So at 8 seconds, so about 8 seconds, it's going to be up here, and that's going to be 16.47 meters of height. And then D is determine the first 2 times the rider reaches a height of 12 meters. So our height has always been our y, and then our x is our time. So this time we're going to put our height in here and just leave x as x, because this is what we're solving for. And then we got to rearrange this whole thing to solve for x. So first thing I need to do is always bring my addition or subtraction to the other side. So I'm going to take the 10 to the other side. So 12 minus 10, I get 2. And then I need to divide this by 8 to get it to the other side. So I have 2 over 8 equals sine 18x minus 90. So what I did here is I just multiplied it in. So I did 18 times x and then 18 times -5. So I get 90. So now what I need to do is I need to bring just the sine part to the other side. So when I bring it to the other side, it's sine inverse of 2 over 8. And then I would have 18x minus 90 on this side. And then I brought that 90 to the other side, so it's plus 90. When you add this up, so you do the sine inverse and add it, and then you have to divide each side by 18, you're going to get 5.8 seconds. Okay? Then, so we know at 5.8 seconds, it's going to reach a height of 12 meters. So about 5.8, there's our 12 meters. Okay, but you'll also see on our graph that as the rider comes down, he'll also hit 12 meters on the way down. So we need to find that time. And since we know that from here to here, it's 5.8 seconds, that means that this here has to be the same time difference. So we know that from here to here, it's also 5.8. So how do we find what this time is exactly? Well, we know at the bottom it's 20 seconds. So if we subtract 5.8 seconds from 20, we get 14.2 seconds, giving me the time when the rider reaches a height of 12 meters on the way down. And that's how you do the first question.